Alright, welcome back everyone. This is lecture 9. I'm going to be trying a new setup with Microsoft OneNote since Microsoft Whiteboard has been crashing just way too many times. It's been frustrating. And I'm also going to be trying to make these videos a bit shorter, hopefully, for your sake. Um, so without any ado, let's get started. So first of all, we're going to be talking today about a couple of rules. So fact, there are rules that make taking derivatives easier. So I'm gonna be going over some of these facts today, some of these rules. We saw last time that the derivative is defined as follows. We define the derivative as f prime of x equals the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x. We saw how quickly this derivative can become complicated. So we can actually use the following rules to find the derivative without having to directly apply this rule. So we use shortcuts to be able to find derivatives. Now, my professor, back when I was in undergrad, used to say, before we go into a neighborhood, we have to know how the neighborhood is so that we don't get robbed. So what this meant was that we need to know the definition of the derivative before we begin to walk in the neighborhood. So the first rule that I will tell you is the constant rule. The constant rule says the following. It says that the derivative of a constant function is 0. That is, if c is a real number, then the derivative in terms of x of c is equal to 0. Okay, so that is the so-called constant rule. And we can see why this is true. We can actually see why this is true. I'll prove it. It's not a quick proof. It's not a short proof. But it is a short proof. It's not a long proof. That's what I'm to say. We can let f of x equals c, where c is a constant. Then by the limit definition of the derivative, of the derivative, we have the derivative of c in terms of x is equal to f prime of c. Well, we know what f prime of c is. F prime of c is the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. But because f of x is c, there's nothing to plug in here for x, meaning this x plus delta x that we typically plug in, that's just equal to c, because there are no x's here. So that means that this limit becomes limit as delta x goes to 0. This piece I just told you is equal to c. F of x is just equal to c as well, because c is a constant. So this is c minus z divided by delta x. But notice that the numerator is 0, so that just makes the whole fraction 0. This is even before we even take the derivative. And we just get that this limit is 0 because we just have 0. We're taking the limit as delta x goes to 0 of a constant. We know that the limit of a constant is just a constant, so that's just 0. So that means that f prime of c is actually equal to 0. So no matter what number you get, the derivative of that number is always going to be equal to 0. So let's do a couple of examples. Let's say number 1, you get y equals to 7. Well, if y equals to 7, then the derivative of y is going to be equal to 0. Why? Because 7 is a constant. 7 is a number. What about, if you're given f of x equals 0? Well, f prime of x is also equal to 0. Again, the derivative of a constant is 0. How about if you're given something a little bit more complicated, like, I don't know, s of t equals to 3? Well, that means that s prime of t is equal to 0, because 3 is a constant. And finally, let's do one more complicated than that. What about y equals k times pi squared? And you're told that k is a constant. Well, because k is a constant and pi is a number, pi is a constant as well, then the derivative of this is also going to be 0. If both of these numbers are 0, are constants, then the derivative of a constant is always going to be equal to 0. So to recap, the derivative of a constant, remember a constant is a number, is always 0.